Good deal. Anyone else come in since the call roll? Okay. Now let's go back to PowerPoint. And we'll go from current slide. Okay. Now, a couple of announcements. One of these is general and one's very specific. The general one is today, Lawson State Community College is sponsoring College Transfer Fair Day. Okay? Long title. They had it yesterday on the Birmingham campus. They have it today on this campus. We get out of class at 9:15. It starts at 9:30. Okay? 9:30 to 11:30. It won't be here in the afternoon, 9:30 to 11:30. And they have a weird touch of naming this. The Bessemer Faculty Campus Cafeteria. It's a strange thing. It's called the Faculty Staff Dining Room. That's what it's labeled as. Let me tell you how to get here. Get there from here. Okay? Here we are in this one classroom here. Go out the door here, and then zigzag a little bit here. You go down this long hallway here until you get to the second stairwell. There's two stairwells in between before you get to the end of the hall. Go to the second one. Go down that stairwell. There it is. Faculty Staff Dining Room. It's actually on the first floor. They list it as the second floor. I don't know why, but that is the Faculty Staff Dining Room. Right over here is the cafeteria. So it's adjacent to the cafeteria. You can come into it from the cafeteria. You can come into it from this end down here or right over here. There's several ways to get into that room. And that's where these universities and colleges will be. And my word, there is a ton of them. Okay? There are a ton. There is a ton. Okay. I'll read off some. AUM, Mississippi State, Oakwood University, University of Alabama is listed a couple times. University of Montebello, Alabama State, Alabama University, Auburn University School of Forestry and Wildlife Sciences, and more from Auburn coming up. Alabama A&M, University of West Georgia, Auburn itself, Jacksonville State, Stillman College, UAB, UAH, University of West Alabama, Troy, University of South Alabama, University of Alabama College of Continuing Studies, that's the third time University of Alabama's here, Athens State University, UAB School of Health Professions, second time UAB's listed, University of North Alabama, Stafford University, Fisk University, Mississippi College, Concordia College of Alabama, Tennessee State University, William Carey University, and this was the new one the student in the last class told me, Avita Institute in Birmingham, that's a cosmetology place, is that right? That's what the student told me, so I'd never heard of it before. Armstrong State University, Faulkner University, Southeastern Bible College, Talladega College, Georgia Southwestern State University, and Berea College. Going to be a lot there. Please consider going by, checking them out, find out what's up. Now, here's one that's very specific to you guys. It's targeted to you guys. That's why I wanted to get this, especially on the screencast-o-matic. Later it'll be on YouTube. A few years ago, only 2 maybe years ago, we started having a math team, okay? And we've had a lot of fun with that. Students have enjoyed it. Believe me, they have enjoyed it. And I think it has helped them big time because you're exposed to some math, thinking math, working together in math and doing things, and really improves your ability to do well in upper level courses, okay? So they usually have their competitions in I think October, in the fall, and so far the first 2 years we've done it, that's when we've tried to put together a math team and have a few practices and go to competition. First year we did fairly well, came in fourth in the competition, you know, but then the next year we didn't do quite as well. So the coach, Ms. Gerasi, some of you may know her from the Birmingham campus, she's wanting to start having practices now, so we'll be ready. That's what the other teams that are successful do. They go at it year round, okay? And it's a lot of fun, okay? Believe me, it is. So she's looking for trying to build a strong math team, and she said if you have a student, and she sent this to us, the other instructors, in Math 100, Math 112, Math 113, and Math 125, or any higher calculus, who will be at Lawson State next fall. Now, if any of you are graduating in spring or at the end of the summer and won't be back in the fall, this is not for you. But for those of you who will be back in the fall, this is for you. So please consider it. Now, what she's going to do, at every Friday at 12 noon, they're going to meet on Birmingham West Campus, the C building. That's the science building. That's that little short building between the library and the B building. In C100. It's a math classroom. And they're going to meet there at noon every Friday. Okay? So, if you want her email address, I've got it. If you want her office number, I've got it. And her phone number. And her office is in the C building also, but it's upstairs in room C210. Please try to do it. Now, if the Birmingham campus is inconvenient for you, and you want to practice here on this campus, check out my locator card. It's in Blackboard, and see when I'm free. I'll meet with any of you anytime. We have a lot of old problems they've given in previous competitions, and we can work through those. And frankly, it's fun. You'll learn a lot of math, and you'll actually help yourself be ready for the next course and courses. Okay? So let me know if you want to have practices on this campus. I'm game. I enjoy doing them. Okay? And if you want to participate with her, Friday at noon in C100, but please email her or call her or go stop by the SEER if you want to be considered for the math team. Hey, we'll take as many as can come. Okay? So please consider it. It's fun. Okay. Have I said that before? Okay. All right, let's see. Why is it? Okay. All right. Any questions on anything we've done up till now? All right, we're in Chapter 1, Functions in the Graphs, 1.4, Functions. Okay? And we're starting this morning on Example 5, page 39. Find all the real values of x for which f of x is equal to 0. So we're looking for all the x's such that f of x is equal to 0. Okay? And here is the A one. F of x is equal to minus 2x plus 10. How are we going to solve that? How are we going to find the x's that make f of x equal 0? Any guesses? What might you try? Say again? Okay, ultimately, you're doing absolutely right. One little step you ought to do first, exactly what it says here. F of x equal to 0. Here's f of x. There's f of x. Set it equal to 0. You're absolutely right. After you set it equal to 0, then subtract 10 from each side. That is a good move. Okay, that gives us what? Negative 2x. That adds to 0 is equal to negative 10. Now what? Divide both sides by negative 2. And that gives us x is equal to 5. Perfect. Now, if you want to check, and that's the only one, by the way, only one. We call this a linear function. We'll name these later. That's a linear function because the maximum exponent is 1. That makes it a linear function. So it should only have one possible solution. And it does. Okay? To make sure it works, plug this back in here. Negative 2 times 5 is? Negative 10 plus 10 is 0. We found an x that made the function equal to 0. Okay? Help me with your name. Say again? Yeah. Okay, I've just got to find you now. Promise. Okay. Good deal. Any others come in since I called roll? Okay, let's go to the B problem. Any questions on this before I delete it? Okay, it'll be out there on the recording, but it's going off the screen right now. Okay, the B part, f of x is equal to x squared minus 5x plus 6. What do we do to find, oh, I didn't write all the stuff down, to find the values of x that make that f of x equal 0? What would we do? Say again? Okay, first thing though, set it equal to 0. That's what we're looking for, the values of x that makes that function equal to 0. And now you're absolutely right, factor it. Okay? Now, if it's factorable, there's no guarantee of that, but let's see if it is. How do you go about factoring? I'll just tell you my little technique. It's sort of dumb, but I unfoil it. Okay? So let's start with the first term. What's the only possible factorization for x squared? X times x. Got it. Then we look at the last term. Okay? What's the sign of that last term? Positive. What does that tell you about these two signs in here? Okay, now if they're one positive, one negative, that would be a negative at the end. If it's positive at the end, that means these two signs have to be the same. And which do they have to be? Look at the middle term. Minus, minus. You're absolutely right. Okay, let me get your name, please. Stephanie, got it. There you are. Okay. All right, then the last thing we do, we look for two numbers that multiply to be 6, and since they have the same sign, add to be 5. Say again? 2 and 3, got it. Okay? 2 and 3. Okay? We have factored it. What do we do with that? Okay? Now here's the thing, folks. Here's the deal, folks. Okay? Anytime you have two numbers multiplied together that yield 0 as a result, what has to be true? Give me two numbers that multiply to be 0. Any two. Any two. Say again? 0 times 0. Is that the only thing that would multiply to be 0? 6 times 0. 17 times 0. Minus pi times 0. Hey. Okay. Any real number, but one of them has to be 0. There's no other way you can get a product of 0 unless one of the two factors is 0. So therefore, we write that mathematically. That, let me get your name. Second. Oh yeah, I'll remember you. Okay, Jasmine, all right. And? Mayfield, got it. I'm hard of hearing. Okay. And you're Kayla, right? Yes. Okay. All right, anyone else come in since the call roll? Okay, so anytime we have two entities multiplying to be 0, one or the other of those has to be 0. So how do we write that mathematically? That says that either x minus 2 is equal to 0, or x minus 3 has to equal 0. Now, can we solve that first one? Sure. How? Add 2 to both sides, and that gives us x equal 2, and over here, no, that's a 3. Yeah, making fun of my writing, aren't you? I got it, okay. Add 3 to both sides, and what do you get? X equals 3, okay? All right. We found all the x's that make that true. Now, did we find them all? Do you know that for sure? What degree is this polynomial? 2. So you can have up to 2 answers. If we found them, don't look any further. That's enough. Let's see if they work. 2 squared is? 5 times 2 is? Say again? Negative 10. All right, negative, okay. So 4 minus 10 is? Negative 6 plus 6? 0, that works. How about 3? 3 squared is? 9. Minus 15 would be? 9 minus 15? 6. No. Negative 6. Negative 6 plus 6 is 0. All right. Oh, I feel like I didn't. Pulling teeth here. Okay. So, yes, both of these work. Okay. So we found the two solutions, two values for x that make that function equal to 0. Make sense? I would say do this checkpoint, folks. Okay. Sounded like there was enough struggle there. You might need to do that. As soon as you can get out of class and have a place to do it, sit down and do the checkpoint. If you can't get it, LarsonPrecalculus.com has the audio-video solution for that. So let's move to example 6. This is also not on the slide set. Any questions on this before I leave it? Okay. Example 6. Finding the values where f of x equals g of x. Okay? So that's what we're looking for. Find the x's such that f of x equal g of x. Okay? Here's the A problem. Okay? Or A problem in general. Okay? F of x is equal to x squared plus 1. And g of x is equal to 3x minus x squared. Okay? What do we do? How do we go about doing that? Help me, help me. What we looked for is all the values of x that makes f of x equal g of x. Guess what we might do to begin with? Do what it tells you to. What does it tell you to do? Set them equal to each other, right? F of x equals, here's f of x right here, there's f of x right here. Here's g of x right there, there's g of x right there. And we want them equal to each other, so make them equal to each other. That would be x squared plus 1 is equal to 3x minus x squared. Now what do we do? That was really the easy part. Where do we go from there? Second? Okay, we want one side or the other to be 0. Absolutely. Why? Because we might wind up factoring. If we wind up factoring, we want one or the other to be 0. See, that principle I told you before, it doesn't work with any number except 0. If you got a 0 there, you got it. So what might we do to get one of those or the other of those sides equal to 0? Give me a first step. Okay, move one of the x squares. Which one do you want to move? You get to choose. You want to know my little rule? Okay, you started with the x squared, that's perfect. Start with the highest power, okay? X squared is the highest power. And then I take the one with the largest coefficient and move the other toward it. Now, which is larger? What's the coefficient here? I don't see one. 1. What's this one? Negative 1. Which is larger? 1. So move the other one that way, okay? And how would we move that way? Add x squared to both sides of the equation. That's a legal move, right? In most states, right? Okay? Now, if we're moving that one, what also must we do? Okay, you want to go on and add it? Okay, let's do it. 2x squared plus 1 is equal to 3x, because that adds a 0. Okay, now what? Subtract 3x from both sides, okay? And that gives us 2x squared minus 3x plus 1 is equal to 0, because that adds a 0. Ha! Now what do? We've got it equal to 0. That's our target, okay? So where do we go from here? Factor it. Excellent. If it's factorable. We don't know that it is, but let's try it. Okay? And where did we start before? First term. So only possible factorization for 2x squared. 2x times x. Perfect. So 2x times x. Okay? And where do we look next? Sign of the last term. And what was that? What does that tell you about these two signs? Got to be the same. You look here to see what they got to be. Negative. Okay, so they're both negative. And then what's the only factorization for 1? Oh, that's tough. 1 times 1. Yeah. But we don't know if this is right. So far it fits all the criteria, but does it work? That's the important thing. How do we check that? Second? Yeah, well, that's what we're going to do ultimately, but I want to make sure that's the right factorization first. How do we check that? FOIL them, okay? So let's FOIL them. 2x times x is 2x squared. Outer is then? Second? Minus 2x. Inner is? Second? Negative x or negative 1x. And then the last is plus 1. And what do those add to? 2x squared minus 3x plus 1. Yes, 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 it worked. Make sure that your factorization is correct, okay? And you got a smiley face, you're happy because it did, right? Okay, let's get this out of the way then. That was fun, but it's in the way now. So let's do what you said. Okay. Now what? Someone said it. Set each of them equal to 0. 2x minus 1 equals 0, or x minus 1 equal to 0. What's that first one give you? What will you do? Help me, help me. You're trying to isolate the x. Once you get it down to a linear equation, solve for x. If it's quadratic or higher, factor, do whatever it can to get it down to linear equations. So what do we do here? Add 1 to both sides. Good first step. That becomes 2x equal 1. And now divide by 2. And what do you have? X equal 1/2. That's pretty ugly, but it's there. On the other side, it's a little easier. Add 1 to both sides, and what does that give you? X equal 1. There we found two x's that we think will make both of these equal to each other. Let's see if they work. Okay? What's 1/2 squared? 1/4. Plus 1 would be how many fourths is 1? How many fourths is 1? How many quarters make a dollar? 4. So 4/4 is 1, right? So 1/4 plus 4/4 is? Second? 1/4 plus 4/4. Okay, 1/4 plus 4/4. How many quarters you got? 5/4. You get 5 quarters, right? Okay, I know this is a weird way to do fractions, but it makes sort of sense to me. If you have a better way, do it however you want to. That's 5/4, right? Okay? Y'all remember your fractions well enough to do that, right? Okay, let's see what this one is if you put 1/2 in there. 3 times 1/2 is? Okay, 1 1/2 or 3/2, right? 3 times 1/2 is 3/2, right? I think in terms of pies, okay? If I have 3 half pies, I have 3 half pies, or 1 1/2 pies. Okay, good. Okay, how about minus 1/2 squared? What's 1/2 squared? It was a long time ago, but what was that? 1/2 squared? You just did it. 1/4, exactly. So this was 3/2. Well, I'll write this one down because it seemed like this is too much talking. That was 3/2 minus 1/4, right? Well, how many fourths is 3/2? Well, if you want a 4 down here rather than a 2, what do you got to do to multiply the 2 by? To get that 2 to become a 4, what did you have to do? Multiply by 2. Well, if you multiply the denominator by 2, what had you better do? Multiply the numerator by 2 as well. What would that give you? 6/4. Ah, we know that, didn't we? And what's 6/4 minus 1/4? 5/4. Ding, 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 ding. That works. Okay? 5/4 over here, 5/4 over there. Yes, that x value works. Let's do the next one. This will be maybe a little harder, but not too bad. X equal 1. What's 1 squared? All right, plus 1. 2. Didn't know you'd be doing such high-level math today, did you? 1 plus 1 is 2. All right, we got that one. Okay. Over here, if you plug in a 1, 3 minus 1 is 2. Yes, both of those work. And frankly, those are the only 2 that'll work because these are quadratics. So we found our 2 values for x that make those 2 functions equal to each other. See how it works? Any questions? Fun stuff to do, right? All right, good deal. And even the book got it right. Good for the, whoa. No, they didn't, did they? Wait a minute. Oh! Oh, no, I'm sorry. I'm looking at the B part. Yes, the book got it right. That was the A part. Let's do the B part. Whew. Beginning to panic there a little bit. Okay? The B part says f of x is equal to x squared minus 1, and g of x is equal to minus x squared plus x plus 2. That's a funny x, but it's okay. Okay. Don't have to sneeze, sorry. Y'all awake yet? All right, good. Okay, thank you. Okay. And remember, the problem is find the values of x that make f of x equal g of x. So what's the first thing we're going to do? A little louder. Does here set them equal to each other? Ah, that's what I was hoping to hear. X squared minus 1 is equal to minus x squared plus x plus 2. Okay? Next. Next step. What do we want it to look like anyway? A little louder?
2x squared.
All right, we're going to add x squared to both sides here. And that gives us 2x squared minus 1 is equal to, these go away, x plus 2. Next. Second, subtract x from both sides. And that gives us 2x squared minus x. Second. Minus 1 is equal to 2. Next. We don't have a rule for a quadratic equaling 2. There'd be an infinite number of things there. What do we need the right-hand side to be? Nothing. Yeah, 0. Okay, so how do we get that? Subtract 2 from both sides. Okay, and what does that give us? 2x squared minus x minus 3 equals, second, 0. Now what do we do? Factor if we can. We don't know that we can, but let's try it. Okay? And where do we begin? Where do do we begin? 2x squared. What's the only possible factorization of 2x squared? So that 2x times x. Got it. Okay, and where do we look next? Sign of the last term, and that's what? A negative. What does that tell you about these two signs? Yeah, they're different, and we don't know which one goes where. So here we do trial and error. You tell me what to try, and I'll tell you if it's an error, okay? You want plus minus or minus plus? Just give me one. Minus plus. Let's try minus plus. Okay, what's the only possible factorization for 3? 1 and 3. But again, we don't know whether it goes 1 and 3 or 3 or 1. So we have some, this is why you don't just assume you got it right. You always check it. Let's see if checking it, what it gives us. 2x times x is 2x squared. That one works. We knew that was going to work. Outer would be plus 6x. Inner would be minus x. And last would be negative 3. What does that give you? 2x squared plus 5x. We want it to be a minus x. Wrong choice. So let's try again. Now, here's a hint here. We've got our number wrong. So let's change our numbers. Let's swap these two. If the sign was wrong, change your sign. If the number's wrong, change the number. So let's go back. Forget all this. That was fun, but it didn't work. Okay? All right. And we'll change our numbers. We'll make the 3 first and the 1 second. 3, 1. Okay? Now let's go through and do it again. FOIL it. 2x squared. Yeah, we knew that was going to work. This will be plus 2x. This will be minus 3x. And this will be minus 3. What does that give you? 2x squared minus x. Ding, 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 ding. Minus 3. We got it. Yes. That's the right factorization. We're really happy, aren't we? Okay. Much rejoicing. Okay. So, we know we got it factored right now. That's why you always check your factorization. Okay? Make sure you got the factoring right before you proceed. Now what? Set each of them equal to 0. 2x minus 3 equals 0, or x plus 1 equals 0. What is the first? What do we do there? Add 3 to both sides, and that gives us 2x equal 3, and then what? Divide by 3. 2. What are you telling me? Okay, 2. Okay, and that gives us x equal 3/2. That's going to be fun to check, isn't it? Okay, next. Subtract 1 from both sides, and that gives us x equal negative 1. Okay. I'm looking forward to that one, not the first. Okay, let's try the first one. 3/2. What's 3/2 squared? 9/4. Is that what I heard? Very good, okay. And we're going to subtract 1, but how many fourths is 1? 4/4, absolutely. So that would be minus 4/4. And what's 9/4 minus 4/4? 5/4, okay. We got those 5/4 again, don't we? Okay, never mind. Let's go to the g of x, okay? What's minus 3/2 squared? Minus, same thing it was before. 3/2 squared is 9/4, excellent. Plus 3/2, that's your x, plus 2. Now, what's ultimately going to be our least common denominator? 4, okay? And how many fourths is 2?
Say again? Did I hear 2/4? That's 1/2. I want it to be 2. 8/4. Perfect. Again, think in terms of food. 8/4 of a pie is 2 pies, right? Ooh, I love pie. Okay. Now, the only thing we still got to do, that 3/2 has the wrong denominator. So what do we do now? We need that one to become a 4. Multiply numerator and denominator by 2, and what does that give us? Same as it did last time, 6/4. So we have a minus 9/4 plus 6/4 plus 8/4. And frankly, here's the way I like to do these. Add the positives together. What does that give you? 14/4 minus 9/4 is 5/4. Ding, 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 ding. That's what we got over here. So it works. Right? That was an easy one. Let's do the other one. Okay? -1. -1 squared is? Minus 1 is? 0. Ain't got nothing to do with it. Okay? So let's try it here. What's negative a -1 squared? Say again? 1. You do the -1 squared. That's a 1. And then you negate that and it becomes a -1. Ew, it wasn't as easy as I thought. -1 plus a -1 is what? -2 plus 2 is 0. Got it. Work? Good deal. And even the book got it right. 3/2 and -1. Good deal. Any questions on those? All right. Let's move on to the domain of a function. Now, we've already sort of talked about this some, but we're going to go into a little more detail. What was the domain of a function? Oh, it was, I know, a day ago. 2 days ago. A long time. Okay. What was the domain of a function? It's all the possible input values for that function. Okay? All the possible input values. Okay? The domain of a function can be described about 3 ways, maybe more. Explicitly. Okay, let me give you an example of this. My younger brother used to work for a small rural electric company over in Georgia. Okay, he retired just about a year ago. Okay, and part of his job, he was sort of the engineer for the company, and he had to do figuring what, if any, rate increases they needed to request from the state, what do they call that, public utility or public service, whatever it was, to see if they needed. So what he had to do, he looked at the past 5 years, okay, and he looked to see what the costs had been doing, the cost of the energy, the cost of equipment, the cost of personnel. He looked at the cost over the last 5 years. He also looked at the number of customers they had. Was it going up? Was it going down? He looked at that over the last 5 years. And he looked at, what the pricing was over the last 5 years. And he tried to put all those things together to come up with a projection, a guess of what might be happening for next year, based on the trends of the last 5 years. So his domain was not the last 20 years, or since the company had been founded. No, that old data didn't do him any good, the last 5 years. So he explicitly described, I'm only going to look at the last 5 years. That's an example of a domain of a function being described explicitly. Or it can be implied by the expression used to define the function. And that's what we're going to sort of focus on. But we will deal with some explicit, but we'll usually do that. Now, the implied domain is a set of all the real numbers for which that expression is defined. Okay? Now, let's go back to one. Okay. How about this one right here? Fx equals x minus 1. Over what values is that okay to do? What x's can you put in there? Here's your first guess always. All real numbers. Everything from minus infinity to positive infinity, perfectly fine there, right? Okay. Not all functions are so nice, though. Okay? For instance, this one. Okay? f of x equal 1 over x squared minus 4. Are there any values that you would have to, you start with the idea, okay, let's assume it's all real numbers unless there's some values you can't have. Looking at that expression, where is that variable located? In the denominator. And what can denominators never be? 0. So therefore, we take that expression, that idea that you just said, denominators cannot equal 0. Well, that denominator is x squared minus 4, and you say that cannot equal 0, right? Is that a true statement? Yeah, you can't possibly do it. So what do we do here to solve that inequality? Wait, I'm used to equal signs being there. Guess what? Same thing works for not equal to. So what would we do? What did we do before? What was the first step we did once we got it into this form? Okay. Now, I hope this won't offend anyone. If it does, I won't ever say it again. Okay? But in this class, when I ask you, what's the F word, what did it better be? Factor. Okay? Don't you get your nasty minds in it. No, I'm just kidding. Okay? The F word in this class is factor. That doesn't sound good, does it? But that's what we're going to do. What's the F word? We factored it, didn't we? Okay? So what do we do here? Factor it. Can that be factored? What do you think? Did I hear x plus 2 times x minus 2? Yeah, that will work. Let's try it and see. Okay? First, x times x is x squared. Outer is minus 2x. Inner is plus 2x. And last is, say that again, minus 4. Okay? And when you combine like terms, what do you get? These two add to 0. X squared minus 4. Yes, that works. Difference of two perfect squares always factors the sum times the difference of their square roots. We knew that, didn't we? Okay? And then what do we do? Let me get all the smiley face out of there. You're grinning at me. Okay? Whoops, I erased too much, didn't I? Okay. Okay? Then what do we do? One a little louder? Not equal to 0, okay? X plus 2 is not equal to 0, and here's the only difference now. Because the product can't be 0, neither one of them can be 0. So both x plus 2 cannot be 0, and, not or. When it was an equal sign, it's an and. Or, not equal sign, it's an and. X minus 2 cannot equal 0. Okay, first one gives us what? A little louder. Subtract 2 from both sides, and what do you get? X is not equal to negative 2, and, second, add 2 to both sides, and that gives us x cannot equal positive 2. So, what is our implied domain here? All real values of x, every one except x can't be negative 2 and x can't be positive 2. And the real easy way to write it is just like they did here. X. Ooh, okay. I like to put the not equal sign here. What they do is say other than x equal plus or minus 2. When I see this, that's what I focused on. If I see not equal to that, I focus on that. It can't be those. But if you put the other than or not or something like that, that's fine. But that's the deal. All the real values. Now, when you're talking about things like that, and the book just says it this way, which to me is if I put a not equal there, that would fit even better. Leave out the other than. All real numbers x, except x cannot equal plus or minus 2. Now, think of that on the number line. Okay? And let's just put our 0 somewhere here. 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4, 5, 6, 7. Okay? Well, here is 0, 1. Here is 2. Can't be 2. Here is negative 1, and there is negative 2. Can't be negative 2. So all these other, every little pixel on the page there can be in the domain. All the little pixels in that part in the domain, and all the little pixels out here in the domain. Just not those two values there. That's all that you're eliminating. That's the implied domain. Now, there's two ways that they usually express this. One, here they just say all real numbers x other than x equal plus or minus 2. I would say all real numbers x such that x is not equal to plus or minus 2. Okay, but if you set it in set notation, it'd be just like what we said. Set of all x's such that, the vertical lines mean such that, x is not equal plus or minus 2. Every other one works fine. And to me, that's the neatest way, that way or that way, neatest way to express it. But from now on, or coming up shortly, the book is going to put it in what they call interval notation. Are y'all familiar with that? Okay, interval notation basically is taking that number line that really looks ugly down there. Where does that begin? Negative infinity. So another way to express this domain, it starts at negative infinity. Now here's a problem, folks. We use parentheses for lots of things. Interval notation, that means whatever's inside there. So negative infinity, and where does it go to? Up to negative 2. So we put a comma, negative 2. Does it include negative 2? It can't include negative 2, right? So therefore we put a parenthesis there. Now that's that first black mess down here, okay? Then we union that with, where does it pick up here? At negative 2 again. Does it include negative 2? No, so we do a parenthesis negative 2. And how far does it go before we have another stop? Up to 2. Does it include 2? No, so we put another parenthesis. Then we do another union. And where does it pick up from there? Does it count 2? No, so we do parentheses 2. And how far does it go? To infinity. Okay, infinities always have parentheses around that. That's not a number, it just means it keeps going and going and going. Okay. If this included one of these endpoints, we would put a square bracket rather than a parenthesis. Square bracket means like less than or equal to. That has the equal to part in it. This is just less than 2. This is less than negative 2. Greater than negative 2, less than 2. No equal sign there, so these are parentheses. Greater than 2, so it would be a parenthesis. So that's the two ways to express it, set notation or interval notation. Okay? I don't like interval notation, but the book does. Set notation says it all for me. Or you could just write it like they did here. Set of all real x's such that x is not equal to plus or minus 2, or other than x equal plus or minus 2. Okay. Now, so let's go back to our domains. If the function is a polynomial, guaranteed all real numbers. If the function has a variable in the denominator, time out, folks. You got to check and make sure no values for that variable will make it equal to 0. If it does, they can't be allowed. So variables in the denominators are the first warning sign. Okay? Now if that had been a plus 4 down here, is there any way that could be a 0? X squared plus 4? No way at all, because you square any number and it's going to be positive, unless it's 0, and then it's 0. Add 4 to it, it's got to be positive. So yeah, you can't possibly have, so that would be all real numbers. Okay? This one though, the denominator could be 0, you have to exclude it. So that's the first thing to look for, variables in the denominator. Does it matter what's in the numerator? Not a bit. Okay? That's just like a polynomial. Anything can be up there. Okay. Well, almost anything. Okay? These two values are excluded from the domain because the division by zero is undefined. Here is the other circumstance we have to watch out for. Radicals. Alpha of x equals square root of x. What is the possible values that x take on there? Give me an x. Give me an x. How much are we? Give me an x. 3. Can you do square root of 3? Yes, you can. It's an irrational number, but you can do it. Give me another x. 5. Yeah, square root of 5, no problem. Give me another x. 12. Square root of 12, no problem. How about a negative 3? Say again? You cannot take a square root of a negative number. You're absolutely right. So what does that tell you about x? Rather than having to write out that x cannot be a negative number, mathematics. By the way, here's my little theory on mathematics. Some of you have heard this before. I don't know if I said it last class or not. When my theory on mathematics, if I think most mathematicians have to be just a tad lazy. Do any of you qualify? No, you're all hard workers. You can still do it. That's fine. But if you're a little lazy, you have a lot better chance of being a good mathematician, I think. Okay? And here's why. Rather than writing out the words, x cannot be a negative number, mathematics has come up with a way to shorten that. Okay? If x can't be a negative number, what does it have to be? Positive or 0. So let's see. How can we write that as simply as we can? X has to be greater than or equal to 0. That says x can't be negative in fewer syllables. 3 symbols, okay? That's all, okay? X got to be greater than or equal to 0, okay? Now, if we wrote that in set notation, that would be the set of all x's such that x is greater than or equal to 0. That's all. We only look at those on the positive side. How can we write that in interval notation? Where does it start? 0. Does it count 0? Yes, it does. Equal to. So we start with that with a bracket 0, and how far does it go? Positive infinity. And infinities are always surrounded by parentheses. Very good. That's how you say it in interval notation. So set notation, interval notation, and here they finally get around to showing that. They don't show set. You just put this inside of the braces, which means it's a set of all x's such that x is greater than or equals 0, or the implied domain is this. So, time out again. The second thing we will look for are any variables inside a radical. Now, whatever that combination is, if it's inside the radical, that thing has to be greater than or equal to 0. That could be x to the 4th minus 3x squared plus 7x plus 17. Okay? That thing has to be greater than or equal to 0. And then you have to figure out what value x makes that true. It could be a negative x in there. Whoa, you can't do a negative, can you? Well, yeah, if x was a negative, the opposite of a negative x is positive, so you could do it. So then your x would be less than or equal to 0. So whatever it takes to make what's inside the radical greater than or equal to 0. In general, the domain of the function excludes values that would cause division by 0 and that would result in the even root of a negative number. Now, if this had been a cube root here, no sweat at all. Cube roots can be, you can take cube roots of negative numbers. You can't take 4th roots, or 6th roots, or 8th roots, or 64th roots, or 112th roots, okay? But any odd root, 5, the 5th root, the 17th root, the 315th root, yeah, you can do that. No sweat at all. Okay, so it's if it's an even root, and if you don't see a number in the up here in the crook of the radical, what do you understand it to be? 2. Everywhere else in math, if you don't see a number, like if you don't see a coefficient, you understand it to be a 1. If you don't see an exponent, you understand it to be a 1. But if you don't see it, a number in the crook of a radical, you understand it to be a 2. It's the only place where 2 is the understood value. Okay? So, beat that horse to death, didn't we? So let's define the domain of each of these functions. Now remember, functions can be written as a set of ordered pairs, either like this or in a table. They can be written as an expression, mathematical expression. They can be written as a formula, or just be given this, or they can be, these are all pretty much mathematical expressions. So that first one, what's the domain of that function there? Domains are always sets, so that would be the set of what? Help me, somebody. -3. I said 3 and wrote 1. -1, 0, 2, and 4. That's an example of an explicit domain. Those are the only values you have for that function. That's all, folks. That's your domain. Okay, so say that a little bit louder. Okay, x plus 5 cannot equal 0, so therefore, say again, all real numbers except, is that what you were saying, except x equal, okay. Go on and get me what x is either equal to or not equal to. Solve that equation, inequality. Solve for x. So subtract 5 from both sides. And that gives you x cannot equal, because these add to 0, -5. So set of all real numbers except x equal -5. Can't have that one in there. Okay. Volume of a sphere. Okay. What is the... Okay, which is your independent variable, which is your dependent variable? Going back to this again. I know that was 2 days ago, so it's a long time. But what's your independent variable here? Say again? Okay, 4/3 is a number, not a variable. V is the dependent, because you choose an R, you come up with a volume, right? So V is the dependent variable, R is the independent variable. Pi is just a number too, okay? It's an irrational number, it's just a number. 3 is just a number, okay? 4/3 is just a number. The variables here are V and R. This is dependent, that is your independent. So your domain is going to be all the values of which? The R's, all the possible R values. So what does R stand for, by the way? Radius. The radius of this sphere, the ball. Basketball, soccer ball, baseball, tennis ball, ping pong ball, whatever. It's a sphere, okay? Now, what are all the allowed values for that radius? Second? You mean all real numbers? Okay. I want you to draw me a ball that has a radius of -3. Yeah, draw me one. A picture of a ball that has a radius -3. How do you do that? That's a good question. You can't, okay? Radii have to be positive. Can you draw me a ball of 0 radius? There it is. Okay. No, it's not one. Right? So therefore your radius has to be all real numbers. Yes, greater than 0, all positive real numbers. So that would be the set of all R's such that R is greater than 0. Not greater than or equal to. 0 equal doesn't give you a ball, okay? A radius of 0, you don't have a ball. 0.1 inches, yes, that's a little ball bearing maybe, but it's really tiny, but it's still got a ball, a sphere, okay? How would you write that in interval notation? where does it start? 0, do you count 0? No. So you put a parenthesis on it. How high can you go? Infinity. There's no limit. Well, yeah, I can't have an infinite ball. Well, maybe the universe would be an infinite sphere. Maybe. Okay, we don't know. Okay, so there's the volume of the sphere. All values for r greater than 0. Not greater than or equal to, greater than. How about h? H of x is the square root of 4 minus 3x. What can you tell me about the domain of that function? What symbol?
4 minus 3.
Okay, what about 4 minus 3x? Say again? It could be. Is that the only value? Okay. It can't be negative, so give me a symbol. Say again? No. It might get up that high or low. Yeah, we see. What is it about what's inside of a radical? What's inside of a radical? This is an index of 2, so it's a square root. So what do you know about the thing in here? What can you not take the square root of? Negative numbers. So this thing in here has to be positive. And how do you write that mathematically? Say again? Okay, 4 minus 3x is what's inside there. How do I write mathematically has to be positive? A symbol. Greater than or equal to 0. Exactly. It can't be negative. It's got to be greater than or equal to 0. It's got to be on the positive side, right? All right. Now, how do we solve that inequality? Help me. How do we solve that inequality? Second, subtract 4 from both sides. That sounds like a great idea. Okay? And what does that give us? Negative 3x is greater than or equal to negative 4. Now what? Divide by negative 3. And what does that give us over here? X, right? What does it give us over here? I didn't divide by negative. It's 4/3. But what about my symbol there? The symbol? Huh? It's not equal. Okay, it's greater than or equal here. Okay, time out, folks. When you're dealing with directional inequalities, okay? Now, I don't know if this is helpful or not. Think of an inequality. This is a greater than or equal to. So that means what's over here has got to be greater than what's here. So it's going to be like this. Okay, just you said which? Yes, he's absolutely right. He flipped it. And here's why. If you have the inequality like this side's greater than this side, greater than or equal to. Okay? Now, if you add the same thing to both sides, it's still going to be like this, right? If you subtract the same thing from both sides, it's still going to be like this. If you multiply a positive number by this, it's still going to be like this. But if you multiply a negative number, that flips the sign and it goes like this. So anytime you multiply or divide a directional inequality by a negative number only, then you change the direction of the inequality. If you're adding or subtracting, stay the same. Multiplying or dividing by positive numbers, the direction stays the same. It's only when you're multiplying or dividing by a negative number does it flip it, so this becomes less than or equal to 4/3. Okay? Now, how would you express that? Well, I'll do it the set notation. That's so easy. The set of all x's such that x is less than or equal to 4/3. And that's a 3, by the way. Okay? Now, how do you write that in interval notation? You're trying to say it before. Which infinity? Oh. Negative infinity. And what precedes every infinity or follows it? Parentheses minus infinity up to 4/3. And what symbol after that? The bracket, absolutely, because you're including 4/3 in there. So yeah, that would be your values there. Because you see, what's in here has to be positive. And if x is big enough, when x is 0, that's no problem. 4 is positive. When x is 1, that's big enough. That would be square root of 1. But if x got up as high as 2, then you have 4 minus 6. It's negative. Can't do that. So it's everything less than 0, less than or equal to 0, 1, and even up to 4/3. At 4/3, 4/3 here, 3's cancel out, 4 minus 4 is 0. That's it. As high as you can go, everything else is. Because the negative 1 here, no sweat. Minus 3 times minus 1 is positive 3, 4 plus 3 is 6. Yeah, negative numbers, no problem at all there. Okay. I hear rattling going on. Y'all are thinking it's close to time to leave, aren't you? Yeah, we still got 34 seconds. Okay, we got more time. Let's just see how they do. The domain was that set of the first values, just like we did. The second one, excluding the x values that yield to 0, that means x not equal to negative 5. The C one was, because a sphere has to have a positive radius, you have r has to be greater than 0. R must be positive. And r greater than 0. Okay? And the last one, the function is defined only where what's inside the radical is greater than or equal to 0. When you solve for that, you get x less than or equal to 4/3. I love the way they do it. Oh, here's the answer. You know, they don't tell you how they got it, but we did. Okay. So, domain is from negative infinity to 4/3 with 4/3 inside the bracket. Okay. Where are we, Waldo? We're right down here at the bottom of page 40. Bottom of page 40. We'll pick up and go from there. Homework exercise. I know you didn't want to leave without those, did you? No, you didn't. Okay? You can do either 5 or 7. Now remember, all the odds are in CalcChat.com, 7's in CalcView.com. Do number 9. It has 4 parts. Do any of the odds 11 through 17. All are CalcChat. 11 is CalcView. By the way, every CalcView has this little symbol there you can read on your phone. Do any of the odds 19 through 29. 21 has a CalcView. Do either 31 or 33, okay, or both if you choose. And these are the new ones. I had all those last time. Here we have any of the odds 35 to 41. 37 is CalcView. Either 43 or 45 or both. 43 is CalcView. Either any of the odds 47 through 55. And 49 is CalcView. And we'll hold off there and pick up the rest of those next time.
All the odds?
Any of the odds in those groupings, yeah. Yeah.
When do you start on math lab?
What's that?
My math lab.
This doesn't have my math lab. This has WebAssign.
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 When we start that?
You can start it anytime. It's out there. I gave you the code last time, right?
Yes, sir.
You can start doing any of that you want to.
Okay.
If you don't want to work these out this way, go find problems in my math lab. I mean, you have me doing it. WebAssign. Okay? I bet you can find these there too. Good deal. Any other questions? Good class? Have a good weekend. You know what will make it good? Working on math problems will make it a great weekend. Okay. And working on your research paper won't do bad either. Will it not, Melvin? No. Oh, yeah. Good deal. I'm sorry? I don't know. Did you come in? Yeah, I think you did. No, I didn't mark you. When did you sneak in? Okay.
I was like 5 minutes late.
Okay, sorry about that. I must have been up here yakking. I can't imagine that though. Yes.
I won't need the website.
You don't have to have it if you didn't purchase it, you don't need it. But I gave you the code.
Last time we didn't use it, so.
But yeah, I really don't care for it because
Okay.
it gives you wrong answers sometimes. No, I said that wrong. It counts right answers wrong sometimes, and it just drives me nuts. But you see, it's a computer program, and always looking for one answer, and you can express it several ways.
Yeah.
4/3 could be 1 and 1/3. Well, it'll mark 1 and 1/3 wrong, but count 4/3 right. They're both right, So, but they certainly have great tutorial help, and you can see some of these problems done. So use it if you want to. This book has lots of other helps, calcjack.com, calcview.com, and also larsonprecalculus.com right here. So it has all these things.
I already used it.
Okay, but you can certainly use WebAssign if you want to.
Okay.
It has good tutoring in it. Yeah.
Try to excuse me when I'm over here trying to get answers. I work nights.
Hey,
Yeah, so-
you're doing well.
Yeah,
You're
I try to
you're
stay
one of the
active.
better
If I don't-
participators
if I
in the
don't-
class. So
if I
I'm-
don't, I'll be bummed.
Yeah. Okay. I'll try not to put you to sleep,
No,
but
you won't. That's why
I'm Mr. Sandman, and I can put anyone to
I gotta
sleep.
get it right this time with my wife's pregnant. So,
Okay. That's
she
your fault.
hasn't-
Okay. No, okay. I'm sorry.
yeah, if I'm not here,
Yeah.
yeah, I'll let you know. I can get an excuse.
Right.
Take her.
Hey,
She
I understand. That's why I record the lectures.
Yeah, but
In fact, I'm recording this conversation. Okay.
Yeah,
So